Hello and welcome to the SUPERSPRINT full build video. In this video I will show you how to build the SUPERSPRINT step by step. While this video should help you to assemble the boat, you might also need quite a lot of information before you even start building it, like the part list, the print settings, and the electronics which you should buy, and also maybe some other information. And this information is in the PDF manual. I will link the PDF manual in the description. The SUPERSPRINT version I am building in this video is the V0. Which is the first one that was publicly released. If you are building this boat later, you might find that there have been updates and your parts might be slightly different from mine in the video. If that's the case, just go on with the assembly, because the key idea of the assembly steps will be the same. If you have any questions regarding the SUPERSPRINT assembly or any other MJet design, feel free to ask in the comments, or you can join the official MJet Facebook group. Link is in the description. Let's go!
I suggest that you print the PDF called SUPERSPRINT drawing, which you can find in the files, and we will start by manufacturing the handmade parts according to the first page of the drawing. The driveshaft and the steering rod will get manufactured from a 5mm stainless steel rod. And the first thing you should check is if the 5mm bearings fit your 5mm rod, because if not, you can just use sandpaper and a drill and a bit of patience to sand the shaft down to the proper size. My shaft fits, so I am just showing this step to you. Now let's measure the shafts to size and proceed with cutting them. It's also a very good idea to round the sharp corners after you performed the cut. Then you need to file flat spots on the shafts to transfer torque, according to the drawing. Be careful, especially when working on the drive shaft, filing the flat spot for the motor coupler, because that's where you might get leaks if you make the flat spot too long, which causes the flat spot to extend into the shaft seal, creating a gap. I am measuring the remaining thickness with a caliper. Once you have the drive shaft finished, just repeat the same process for the steering shaft. The next step is to cut the motor mount pins and the steering pin from a 3mm stainless steel rod. Here I like to round the edges using a drill and a file. And lastly, we will manufacture 3 water cooling tubes by cutting them from 3 by 4mm brass pipe. It's also useful to clean the inside by using a 3mm drill. And these are all the handmade parts done. Let's now test if the impeller fits the drive shaft. This is how it should look like, the impeller sliding quite freely on the shaft, without using too much force. The next chapter is manufacturing the flotation. You don't have to do this at all, this is completely optional, but it helps to make your boat safer, and in case of an unexpected accident, the flotation inside of the hull will keep the boat afloat. To cut the flotation accurately, I am using the flotation templates from the SUPERSPRINT drawing, printed on paper in the actual size setting. Then I am transferring this onto the foam I am going to use to be able to cut it to size. The flotation templates are designed for 28mm thick foam sheets, but you can totally use a different thickness if you have it, because the flotation drawings will just help you get the right shape. Then you need to cut the flotation about 3mm smaller than on the drawings, because the drawings just show the inner surface of the hull without taking any tolerance into account. And these are the finished flotation pieces. Now let's start fitting them into the hull. Starting with hull front. And continuing with hull middle. If some of the pieces are too difficult to fit in, you can also cut them in half for easier manipulation. I was able to fit in almost all the pieces, but it's normal that some of them stay left over. And this is the flotation finished. We will remove it from the hull again for the next steps. The next chapter is to insert various hardware into the rear hull. I find it easier to do it this way rather than after the gluing. I am starting by pressing in the threaded inserts for holding the turn fins. Then you need 4 inserts which will be holding the pump. And 2 inserts for the motor mount. On the SUPERSPRINT these 2 go in straight. Then the main bearing, which is 5 by 13 by 4 mm. And here I am cutting off the first fat layer from the steering shaft seal slot. In this area you need to be a bit careful when inserting the seal, because if you make the slot too big it will leak. If you make it too small, you will break the seal while inserting it. So just do it just right. A few taps with hammer are fine. Then the seal should end up being lined up with the rear surface of the hull, not extending above it. And now the main seal for the drive shaft. I am inserting both of the seals with the spring facing down into the hull. We can also test fit the drive shaft to see if everything is aligned properly. Now we will be using epoxy, and I recommend that you use some paper tape to mask off the important areas, such as all threads, some parts of the pump, because you definitely don't want any glue accidentally dripping into one of your threaded inserts, blocking the thread. And the first parts we are going to glue are 2 of the water cooling tubes, and we will use them as inlet and outlet for the water cooling. The jet pump will be supplying pressurized water into our water cooling loop. You don't need any dedicated electric pump for this. While the epoxy is curing, we can use this moment to not forget about the battery mount screws, because they will be much harder to insert after we glue the hull together. So use 2 times M3x20 and screw them into the hull middle. Finally the time has come to join the hull together. I am using 5-minute epoxy here, which is quite fast, but you can definitely do it in 5 minutes. The joint interface is designed to align itself, so you shouldn't have any problems aligning the hull together. And just place some weight on top of it once it's done. Of course, excess epoxy will start flowing out, so take care of it and you won't have to do it later. Then let's proceed with gluing the hull front. This is the same as before. Here this is a bit unstable, so you will probably have to support the rear hull, but you should be able to place the weight on top in the end. The last important glued joint is the lid base. Here I recommend that if you want to stay calm, you use more than 5-minute epoxy. Okay, good job on the last glued joint. Now, because I want to paint the bumper together with the boat, I will attach it now using 2 M2x8, but you can also attach the bumper after the painting if you want. Before applying any paint, I will also cover the rest of the threaded inserts with a paper tape to prevent the paint from getting into the threads. I decided that the SUPERSPRINT was the perfect opportunity to paint flames on a boat again. This time I will go with blue flames, which will match the color of the rear wing. Here I really liked what I did with this hull. To completely seal the 3D print, which might not be watertight by itself, I recommend using some kind of clear coat. I am also masking off the lid interface to prevent any drops in that area. Instead of clear coat, some people use epoxy resin, which also seems to work. I am also spraying the clear coat on the inside of the hull and into the float chamber. This will all help you to get the boat watertight. Apply multiple layers of this. With the clear coat done, we almost finished the hull, and now it's time for the other parts. I am starting by assembling the pump and inserting 4 threaded inserts into the bottom to hold the intake grate and the right plate. To easily insert the bearing, you can use the shaft to help yourself, and you can even use the impeller as well. The last piece of work on the pump is to insert the grab screw, which will hold the nozzle. I am using a little bit of epoxy to firmly secure it in place, because you are not meant to unscrew this later. Let's continue by pushing an insert into the servo coupler. And now let's press fit the steering shaft into the steering crank. Pay attention to correct orientation of the flat spot. Also press fit the steering pin. And now the steering shaft assembly is finished. Let's take a look at the assembly of the dry box for the receiver. This part is completely optional, but because receivers are very vulnerable to contact with water and might stop working and losing the signal, I like to use this part myself. It is designed for 2 servo extension cables, which you pull through the slots. After you find their correct position, you can use tape to secure them. And then you fill the channels for the cables with epoxy, making a complete seal. After the epoxy cures, you can remove the tape, straighten the cables again, and then you also need to glue in the last water cooling tube. This time this will be for the antenna of the receiver. The receiver gets mounted in a horizontal position using zip ties. The idea is that if your receiver has gyro, this position will enable you to use the gyro properly. Now let's push the O-ring into the slot and close everything, using 3 and 2 by 8s. Then you just pull a water cooling tube over the antenna, you cut it to length, and you blind the end of it, which will create a complete seal of the dry box. Let's also push 2 threaded inserts into the dry box mount. And our next chapter is the deck. The deck will hold the pilots, the engine and the roll cage. The pilots get mounted using 2 M3x8 with a flat head. The roll cage front also gets mounted using 2 M3x8 with a flat head. And the roll cage rear just as well. Then just use 3 times M3x20 to pull everything together. And finally the engine gets mounted using M3x8 with a flat head. Let's assemble the frame locking knobs as well. You just need 2 standard M5 nuts. Next, let's do the motor mount. First, you press fit in the 2 motor mount pins you manufactured in the beginning. Using a vise is better than using a hammer. But after doing this, there might be a little bump on the other side, and I suggest that you flatten this out with a knife, because otherwise it could throw your motor out of the correct position. For all information about the motor, please read the manual, link is in the description. Right now I will be using a 1400 kV 3660 motor on 6S. My brushless motor didn't come with a cooling jacket, so I am just attaching one. Then take the servo coupler and your circular servo arm and find 2 matching holes there. Then drill those 2 holes in the servo arm with 2mm bit. Firstly, put the screw which will be securing your servo to the servo arm in place, and then screw together the servo arm and the servo coupler using two M2x8. Leave a 1mm gap to compensate for any misalignment. Also screw in the M3x10 which will be holding the steering shaft. Now attach the servo. Information about the servo is in the manual. Use two M3x10. Just make sure that the servo is centered before the installation. Attach the servo coupler to the servo with the M3x10 screw pointing upwards. And then you can attach the motor using a combination of M3x20 and M3x10. Use as many screws as possible, but this depends if your motor has 4 or 6 mounting holes. Take your motor coupler and apply some thread locker before tightening the grab screw. And this is the whole motor block finished. I suppose that by now you have already applied enough layers of clear coat to be sure that the hull will be watertight. You can remove all the tape and put the flotation back in. There might be some drips of epoxy under the lid base area, because this is where the ESC needs to go. Make sure to clean this off, and then the ESC will slide right in like this. Let's also install the last two remaining grab screws into their positions where they will hold the frame of the deck. These are not supposed to be removed again, so I am using thread locker. You can also use epoxy instead. Attach the rear wing using M3x10 in the back and M2x8 in the front. Now I am taking the optional step and gluing in the receiver dry box mount. After trying this with the SUPERSPRINT V0, I realized that the dry box is a little bit too big, so be careful when installing this and choose a position where it doesn't interfere with the cooling jacket of the motor. Only after checking that, install the dry box mount. Now it's time to cut a sticky velcro for the battery mount. Stick this into the whole battery area and stick the opposed velcro to your battery itself. "3D print the little battery strap loop and use it to create a velcro loop, which will then tighten over the battery and it will create a really strong mount. And the battery is not going anywhere. Next, let's prepare the ESC. The ESC needs to go all the way into the back, which requires the cooling loop here to be quite tight. So cut it just enough so that the silicone pipe doesn't get too twisted, but also doesn't take too much space. Attach a sticky velcro on the bottom of the ESC. And attach the opposed velcro onto the float chamber wall. One of the main reasons to use this ESC position is to improve the self-righting, thanks to shifting the CG to the left side. Before inserting the motor mount, also attach the two water cooling pipes to the inlet and the outlet, and definitely secure them with two zip ties, otherwise they might blow off and you will get the hull full of water. The motor mount gets attached with one M3x40 and one M3x20. After this step, it's just a matter of connecting everything together and somehow making order in the amount of water cooling pipes and cables. The water cooling loop goes like this: first from the inlet into the motor, then from the motor into the ESC, and then from the ESC into the outlet. But you can also change the order of the ESC and the motor, it's really not that important. Looking from this angle, you can see the outlet on the left side. And as you can see, I managed to get the cables quite tidy. Now I am connecting the receiver with the cables and then with a little bit of difficulty inserting the dry box into the hull. I ended up removing the dry box mount, after that it fits quite nicely. Now I am inserting the drive shaft into the hull and I will secure it with a grub screw in the motor coupler, but before that I will definitely apply the thread locker. The impeller will slide on smoothly, and here it is totally essential that the impeller is touching the bearing, because it needs to transfer all the thrust into it and not into the shaft. The shaft should be sticking out about 5 mm from the impeller. Looking at the pump, notice that there is the top stator vane missing. Use this to your advantage and rotate it smartly to slide it over the impeller effortlessly. Attach the pump with 4 M3x10. Now I am applying some grease. I am using white lithium grease, but you can use any thick grease. I am applying it into the grease port on the pump and also in the grease port in the hull. This should improve the seal and extend the lifetime of the bearings. Close the grease ports with 2 M3x6. Then you can insert the steering shaft and secure it in the servo coupler using M3x10, which is already there. Then attach the nozzle using an M5 washer and an M5 locking nut. Don't tighten this, because the nozzle needs to slide freely. On the bottom, insert the intake grate and secure it with 2 M3x6 with a flat head. And also use 2 M3x6 with a flat head to secure the right plate. Then use 4 M3x6 with a normal head to attach the turn fins if you want. And that's basically it. Now let's just connect the battery and see what happens.
And that was the last step of the assembly. Congratulations if you finished building the SUPERSPRINT. And now go and make your boat fly.